model-based testing on shortly MBT passed in test automation, because if you are using test automation without page object models, it will dry, it will not be, don't repeat yourself. On the other hand, if you are using a page object model, then you should write a lot of code. And you can use either of the methods. Obsolete test cases will remain, which is not a good thing, and it's very difficult to delete the obsolete test. And the biggest problem is with simple test automation, which some people call test execution automation, not test execution, not test automation, that you can find only simple bugs, because you are writing the test code one by one, and this is an ad hoc testing without any test design. Because in this way, there is no test selection criterion. The test selection criterion says when you should stop testing. When you can, it's not to write another test case. Okay. But if you are using model-based testing, that it's inherently use the dry solution, and obviously each model is more compact than writing a code. And the quality will be much higher because you can use a test selection criterion. And another big advantage is that not only test automation engineers can do it, but manual testers, business analysts, and so forth. Okay, there are a lot of different classification of MBT, but my classification is very simple. There are two traditional ones, stateless and stateful, and the new one, aggregate. So let's start with stateless MBT. These are business process models, such as BPMN, UML activity diagrams, or use cases. Obviously, use cases is a textual modeling, but no problem because each model can be converted to a graph. And based on the graph, you can select a test selection criterion by traversing the graph in a different way. Okay, here the information is the user actions, mostly the responses, but not the states, and that's the problem. The good thing is that stateless MBT can be used generally for each system, and there are lots of such tools because it's easier to implement. For example, Broadcast, Agile Designer, Eggplant, Perfecto, Curiosity softwares, Modeller, and so forth. Okay, here are the problems with this method. The first is that there are invisible paths, because when you are generating test cases, then there may be invalid test steps. For example, if the last step is that you add a third bike into the cart, and the next step is to remove the second bike, it's not possible. MBT tools offer some constraints. For example, transition B cannot follow transition A, but it's too simple, and that's why so-called guard conditions should be involved. The guard condition describes when an even action can happen, and this is just coding, so you want to remove coding, but it's not possible because of the guard conditions. For example, if the maximum number of the tickets is 10, guard condition is that ticket number is less than 10. And another problem is that only simple bugs can be found because there is no states. Okay, to demonstrate what I'm saying, here is a relatively simple example with the requirements. The first requirement is that we can add bikes and cars one by one. Reversely, we can remove bikes or cars one by one. And if the customer rents vehicles for at least 800 euros, then they can get a free bike in a different way. If the customer previously selected a bike, then this bike will be converted to free. And if there was no bike at all, then a bike added freely. Okay, and the last requirement is that if the customer deletes some vehicle to get below the discount threshold, then this will be withdrawn. But it's important that if the customer adds the car again, then he gets the free bike in the same way as before. Okay, it's not too simple, but I cannot find a simpler example. So here is the model. This is a stateless model where the edges are transitions or actions, and the nodes are responses. It's obvious that from the start point, we can only add or delete a bike. We can add the bike or add the car. I will ignore the stop node because it's not important. And from all the other nodes, we can add and delete a bike and add and delete a car. Okay. And the good news is that based on this model, you can select each test cases. So you can traverse this graph to cover each test case which is possible. But there is a problem, the invalid path. You can see here. So first I add a car. Then I delete a car, and I delete a car again. But in this way, we have -1 car, which is not possible. Okay, you can see, you can think that a constraint can be a solution, so that we cannot have through car deletion in a row, but it's not true. Because if we add another car, then this constraint is not good, and therefore we should apply the guard condition. For example, for the bike deleted node, we have a guard condition that the number of bikes is greater than or equal to 1. And in addition, we should have some more. For example, the initial statement is that the number of bikes is 0, and if we add bikes, then we should increment the number of bikes, and if we delete a bike, then we should decrement the number of bikes. Okay, and finally, you can see that only the responses are here, but not the outputs, because in the model, we don't know the output, because if we traverse the graph in a different way, then the output will be different. So we cannot involve the output into this model. Okay, and stateless MBT doesn't detect all the bugs. For example, here is a test case. It's obvious that each requirement should be covered by at least one test case. And here is the test case. The first step is to add some vehicles, to add a free bike. The second is to delete the car, to withdraw the free bike. And finally, we should add another vehicle to obtain the bike again. This is L3C. Okay, and let's select a test selection criterion that is not so simple. This is all action pairs, which means that all adjacent transitions or edges should be covered. And to fulfill this criterion, we should have these 12 test cases. But you can see that not only T1 will not be covered, but even the first step will not be covered, because to cover the first step, we should add 3 cars or 2 cars and 2 bikes. But in this test cases, there are no 3 additions in a row. Okay, now let's move to the stateful MBT. And I should stop here. So test community likes to borrow different methods from computer science or software engineering, such as use cases and with respect to state transition testing. And if you are surfing on the net and try to find some examples for test for this method, you can find the same examples for ATM, for example, clock setting and calendar setting, which has only 3, 4, or 5 states, but no more. But in real systems, there are lots of states. And the original definition of when a system is stateful is that if a system gives a different output for the same input depending on the earlier state. It's good for software engineering, but it's not good for us, for testers, because the reality is that if a system calculates the output differently for the same input depending on the earlier state, then it's test stateful. With the original definition, the problem is that if you add another bike to the cart, then the output will be different, because the output will be 1, 2, 3, 4, 5. But if you add more another state for each addition, it's the number of states will be whatever, millions or trillions. But if you add a new state only if the computation is different, it's good, because if there is a different calculation, the developer can make a mistake and you should test it. Okay, so let's continue. So here the models are state transition diagrams or extended final state machines, etc. And obviously they are graphs, and we can select test selection criterion, and here the information is the user actions, the system responses, and the states. And with this method, you can find even the tricky bugs as well. Okay, the problem is that sometimes it's difficult to apply, and that's why there are much less tools for this method, only OPKey and Conformic Creator, and obviously lots of academic tools. Okay, and we arrived the most difficult part of my presentation, how to create the states in our current example. Okay, we start from the initial state where there is no discount and no bike. And if we add the first car, for example, is the first computation, and if we add another car, then we do the same computation. So we haven't arrived at a different state. But after we add the third car, then we arrived at a different state because the computation is different, because not only the third car has been added, but a free bike as well. So it's a different computation and a different state. Okay, and if we add a bike in the beginning and after then the three cars, then there is another different computation, because now the bike is not added but converted. So it's different. Okay, I stop it because I know it's not too simple for the first time, but you can see that instead of having millions of states, we have only 4 without the stop, because but I ignore stop because it's out of the example. So here is the state chart for the same example. You can see that we have the same 5 states, say 5 nodes, and we have a little bit more transitions, edges, but it's not significant. This is because from a given state, we can go along the same transitions to different states, different nodes. Okay, so here is the same test case, and I show you that by applying a good test selection criterion, then selection criterion will force to cover this test. The test selection criterion is the same, all edge pass criterion, and we should go along each transition. So first we go from the start to the discount bike added, and then we should go back. And because each pair should be traversed, we should also go back to the discount bike added state. And these 3 transitions are just the 3 steps in the test case. So we covered. Okay, unfortunately, there are also invalid paths. For example, if we add just a car, we cannot go to discount bike added, because first we should cover add car twice. Okay, that's why we should add guard conditions again, and the guard condition is that the total price should be greater than or equal to 500. Okay, and here is the problem. When you code the guard condition, it's just the output. But we are in the modeling phase and we just want to test the output. But here, instead of we model the output, we should code the output. So it's not a good thing for this stateful method. And now we arrived at the new method, the aggregate model-based testing. And there is only one specific method, is action state testing. So what we need is to consist the states only optionally and not obligatory, and we don't want to write any code. Here, the action state testing, we have a textual model, and it consists of steps, and each step consists of 3 sub-steps. The first is the action. This is obligatory. The second is the response. It's optional because you don't need to check after every action. And finally, the state, the test state, which is optional. Here's an example. The action is at the car. The response, which is also an output, is that one car is in the cart, and the state is that we remain in the initial state. Okay, it's very important that the actions and the responses should be as abstract as it can be, as possible. Here is a very abstract action: add items so that the price remains below 10. It's really very abstract because the tester can understand, and he or she can do it different way. A more concrete but still implementation independent solution is to add an item first for 7, then second for 2. It's 9, it's below 10. It's okay, and we can have an implementation dependent way. So first click on the plus icon next to Pizza Mexicana and click on the plus icon next to Coke. This is implementation dependent, and it's not a good solution because the abstract actions and responses should be understandable only for the testers, but not for any test automation tool. Action state modeling is very simple. On the left-hand side, there are 2 steps, and because step B is shifted right, then this will be translated to one single test case with 2 steps. On the right-hand side, both steps are in the same indentation, and here we have 2 test cases with one step. Okay, as I mentioned, we can omit both the response and the states, and we should connect or map the requirements with the model and the test cases. And on the button, you can see a label R1, my requirements A. Okay. An advantage of this method is that the original textual model can be converted to a state chart. And a state chart consists of less information, but it's very good for validation. I will show you. And based on this, we can select different test selection criteria. So, in action state testing, the states may be involved, but not obligatory, and can be converted to state chart for validation purposes, and we can use any test selection criteria. But a very important advantage is that here there is no invisible path which generated, but we have maybe invalid steps because this method offers some missing step. But you can easily check whether a step is valid or invalid. For example, if the last existing step was that the cart consists of 3 cars, then a new step which says that you remove the second car, it's obviously invalid. This consists of all the necessary information, user actions, system outputs, and test state. And really, no code is necessary, and the outputs are involved. which is a very good thing because you don't need to set the outputs after the modeling. And we can find very tricky bugs, and it can be generally used. There is only one such tool, it's Harmony. And here is an example. We start with the initial state, and here is the label. To that we can add a car or a bike one by one, and you can see that we can add 2 cars and we will remain at the same state, or we can add the bike. This will be a different test. Okay, you can see the related state chart, and you can see that it doesn't show that add car is traversed twice. And on the right-hand side, you can see the generated 2 test cases. These are also abstract test cases, but a tester can understand and execute. Okay, if we cover all the 5 requirements, then this is the model, and the question is whether is it enough. Here is the relative state chart, and you can see that lots of actions are missing. For example, on the left, discount bike added. It's a very single state because there are no transitions from here. For example, adding a car, adding a bike, or deleting a bike. So covering the requirements is not enough, except if the risk is very, very low, because a minimum test selection criterion is that you should cover each transition, each action at least once. Okay, and the next question is how to execute the test cases, because we have an abstract model, but we want to execute. Okay, and okay, we apply a test execution tool, Cypress, for example, and I started Cypress, and I set I will set the directory for the test, and I press T1, and the test executed. Okay, and I stopped here because you can see on the left the action. Add items so that the price remains below this. This is the action. So I just test it by adding 7 and 2, and now I validate first that the total price is 9, and then it's more difficult that the pay button hasn't been active because it will be active only when we reach 10. Okay, so I will select the non-active here. Yeah, and is the first step, and the next step is when I delete Coke at the beer, I reach 10, and I validate that this is 10, and now that it's active, the pay button is active, and the test case is done. And now I should re-execute the whole test, because some problems may be missing, and that was the execution. So the test is ready. So from the model, you can very easily make an executable test case. The difficult part is the modeling, not the test execution part, because it's just click and click and click. Okay. And finally, the conclusion. I considered 3 MBT methods: Stateless MBT method requires coding, but cannot find tricky bugs. On the contrary, Stateful MBT requires coding as well, but and can find every bugs, but cannot be generally used. And here is action state testing, where we are using simple test states. Doesn't require coding, can be generally used, and outputs are included, which is really very good. And we can prove that very tricky bugs can be found. The models can be improved by the related state chart, and it's really a shift-left solution because it's implementation independent, and you can start creating a model right after the requirements are ready. Okay, I'm finished. You can exercise via flying or web page, and you can try harmony. Thank you again.